All right, folks, this is one of our classwork problems where we want to use the definition of a fraction to answer this question. And the question says where is 1/3 on the number line? So we want to locate exactly where 1/3 would live. All right. And so what we want to do is we sort of want to talk our way or step our way through the definition of a fraction as we approach or consider this problem. So part one of the definition says establish a whole. All right. So here I've got my number line, and on it I see a 0 and a 1. And so in this problem, the whole is already established for us. All right. So we just want to acknowledge that we're given a distance between 0 and 1. That's a whole. That's one whole unit. Okay. So step two, if we're trying to locate the number 1/3 on the number line, then step two of our definition would say that at some point we need to split this whole into 3 equal length segments, right? So we need 3 equal segments, and then we can collect one of them, and then we've got 1/3 of our whole. Alrighty. So I see a bunch of tick marks though here. I see 1, 2, 3, 4, 5, 6 little tick marks within our whole, which means that our whole has already been split up into 7 equal length pieces. All right, so I just account if I want to 1, 2, 3, 4, 5, 6, 7. So I've got 7 pieces right there. So let me go ahead and label these pieces. So I'll introduce how I want to label fractions on my number line. So personally, I like to put, if I have whole numbers, maybe put those up top. Maybe you want to put those in the bottom. But maybe on the opposite side of the line, let me call, if this is one whole and I've got 7 equal pieces, then if I collect one of them, meaning I move over here, and if I wanted to shade it in a little bit I could, or just indicate that this mark I could label as 1/7, right? So by moving from 0 over to here, you could say I've sort of collected that 1/7. And if I move over another one, I've collected 2. Each one of these pieces represents 1/7 of the whole, because we've got the whole broken up into 7 equal parts, and so this would be 2/7. All right, and if I move over again, I'm up to 3/7. So we can associate the tick mark with the length of the segment that we would get by going from 0 all the way to that tick mark. All right, so if I say I'm collecting the pieces, here I'm kind of shading them in because the original line was not that dark. And so just to sort of reestablish this line in my dark black pen. So here I've got 4/7. Next I've got 5/7. Next, if I collect it, this mark refers to the length of 6/7. And then finally, the whole number 1. I established my whole, which establishes our denominator of the fraction. I'm sorry, that's the second part, actually. I've established my whole, which is the 1. I split it up into 7 equal segments, which gives us our denominator. And then however many I move over to the right or collect or shade, that's what becomes the number, the digit in my numerator. And so here, this is going to be 7/7. All right, and we're probably familiar with that fact from our own upbringing with fractions, that if the numerator matches the denominator, then that fraction is equal to the whole number 1. But now we know why, because if we step through our definition, we first have the whole, right? You have a whole pizza, you cut it up into 7 equal sized pieces, and then you eat all 7 of them, right? You were really hungry, and so how much of the pizza did you eat? 7/7, but you ate that whole pizza, right? Okay, good enough. So we've got this is everything that was given to us basically in the problem, except now we just labeled it up a little bit more and explained it. So now I want to figure out where 1/3 lives. All right, so that seems a little challenging at this point. I could pretty much figure out where 1/2 would live. Right, I claim 1/2 would live right there between 3/7 and 4/7. How do I know that exactly? We'd have to argue that, but I claim that 1/2 lives right around there. If I split that distance in half, and that gets a little hard to sort of make jive with these marks, but if I split that in half, let me put sort of a question mark arrow, right? Then 1/4 maybe lives right around there. And so just from my own sort of experience, 1/3 should live somewhere in between there, right? But it's really sort of an estimate. I want to know exactly where it lives. I don't want to say it just kind of lives in this region over here somewhere and call it a day, right? We want to figure out exactly where that fraction is going to live on our number line. So how are we going to do that? We want to split our whole into 3 equal pieces. That's what we need to do to accomplish the second part of our definition for this fraction. But we've already got these 7s established. We've already got our whole split into 7 equal pieces. So is there a way that I could collect maybe 2 of the pieces, maybe is 2 of them, 2 of them, and 2 of them, but then I've got this extra piece, right? So that's not quite going to link up. So how are we going to do this? So let me grab another pen. Grab my blue pen here. And just think about, we kind of just said I've got 7 pieces, and I know that I cannot form 3 equal groups from there, right? Because then I would have sort of 1 left over, 1 remainder. So 3 doesn't really go into 7. I can't take 7 and break it up evenly into groups of 3. So what if I were to, I said earlier if I wanted to locate 1/2, then maybe I wanted to split this segment into 2 equal pieces. Right, so what if I split every segment into 2 equal pieces? Would that help us? And so I've got 7 original pieces. If I split each original piece into a group of 2, I would have 7 groups of 2, right? And we remember from Math 107A that the order we multiply tells us sort of how many groups we've got and then groups of what, right? So here I've got 7 groups of 2 items. And so if I were to split each of these 7 segments into 2 equal pieces, I would end up having 14 smaller pieces. Okay, so maybe that's a strategy. However, if I've got 14 smaller pieces now, can I form equal groups of 3 of them, or 3 equal groups of those smaller pieces? And you might say, no, if I had 12, right, I could form 3 equal groups. If I had 15, I could form 3 equal groups. But if I've got 14, it's not going to work. Similar problem with 7. We're going to get a remainder. We're going to have a few pieces left over. Okay, so that doesn't seem, it seems promising, but doesn't seem like it wants to work out. What if I took each one of these segments and split them up? So if two smaller segments didn't work, maybe 3 smaller segments per segment. Okay, so let's say I do that. I take each of these segments, these black segments, and I split them up into 3 equal length segments. Then I will have 7 original segments, which each now is becoming a group of 3 smaller segments. And we know 7 times 3 is 21. Okay, and so if I were to do that, then I would have 21 small segments, and from there, now can I form 3 equal groups of those smaller segments? And the answer is yes. All right, so you might say that's obvious, right? I have 7, I want groups of 3, so 7 times 3 is 21, right? But we're sort of thinking about this from the ground up. We're sort of just exploring, how can I create equal length segments along this line, and then count up some of them, to locate exactly where this lives, okay? So now I'm going to do the best that I can to create equal length segments, 3 equal length segments within each of these. And so just to break off for a moment, in the past, I've seen this on some papers, so I'll try to nip this in the bud right off the bat. We want equal length segments in here, 3 equal length segments within one of these. So that means I have to add 2 tick marks. I've seen this before, so 2 like right there, like that. Right, but what's the problem here is now I've got one really long segment, then a tiny little one that doesn't really belong, and then another long one. Right, so it does take a little bit of practice. If you want to sort of break out a tape measure and try to split these up perfectly, you can. But to use a tape measure, you're kind of taking advantage of fractions already, and we're trying to pretend that we really don't know too much about how this all works. So let me just do my best. So I'm going to put 1, 2 little marks right there, and then that would be the 3rd one. And do it again. So 1, 2 little marks, and I'm striving for equal length segments here. And I'm going to do that throughout all of these 7 original segments. Okay? And if some of the marks aren't perfect, that's okay. I'll live with that. But we're striving for perfection. Right? That's going to be our motto in here. So I set this up. If I want to trust my arithmetic up here, we had 7 original segments. Each one is now a group of 3 smaller segments. So 7 groups of 3, 7 times 3 is 21. But when in doubt, count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Perfect. Okay, what can I do? Now with this blue pen, let me go over here and write 21 over 21. Is that a fair representation of my whole, my 1? Sure, right? At that point, we're sort of acknowledging the rule that we already remember from our own past, that 7/7 if the top matches the bottom, then that's a 1. But right here, this adheres to our definition. I've got a whole split into 21 equal length segments, and if I move all the way over and collect all of them, then I've collected 21 of those 21, okay? If, I will occasionally put things in a little thought bubble. If you're thinking, oh yeah, of course those equal each other, because 7 times 3 over 7 times 3, because that's equal, right? And then 7 times 3 is 21 over 21, then I don't know if you can see that great with my purple. At this point, I'll say you could go from here to here, because 7 times 3 is 21. So if your numerator was 7 times 3 and your denominator is 7 times 3, then you would get to here. But how do we know that this is equal to this? Okay, so you might remember from Math 107A that one of the struggles of this type of course is things that we already know, or that we think we know because we learned it one time. Before we can go ahead and say, oh, and use it in here, we have to justify it from the definition up, right? Build it up from the ground up. So this rule right here, we will prove together in the course, but we can't just take advantage of it right now and say, of course, 7/7 is the same as 21 over 21. We have to rely on that definition right there. Okay, moving on. We want to locate the number 1/3. So now let's think about our definition. We'll go back to our definition again. So now I want to split my whole. I've got 21 small segments. I want to split my whole into 3 equal segments. So I want 3 groups of the small segments. So I already have this multiplication in my head, but sort of what I'm building now is I want 3 groups of something, right? I want to collect 3 groups of some number of segments, and I want to ultimately collect them all and have that equal 21, right? So now as I group these segments up, this is what I'm thinking. And so this is sort of missing factor, right? This was sort of our definition, or this was our definition in 107A of division, is we converted it into missing factor, right? What are we really trying to do here? We're trying to take 21 and divide it into 3 equal groups. And so we're looking for this factor. We know it's 7. So what I want to form here is 3 groups of 7. So to do that, let me do 1. I'm going to use dots here. 1, 2, 3, 4, 5, 6, 7. I'll use those dots for the first segment. So what I want to do is collect 1, 2, 3, 4, 5, 6, 7. And now that blue tick mark right there, let me overlap that with a green tick mark that's a little bit more demonstrative, so we see that. And now let me do, maybe I'll do a little X here. 1, 2, 3, 4, 5, 6, 7. So I marked off the next 7 segments right there. We're looking for groups of 7, so there we go. Let me overlap that blue mark with this large green mark right here. And I always like to count to the end, just to make sure that everything's working out. So I should have one more group of 7. 1, 2, 3, 4, 5, 6, 7. Let me put a little check mark. 1, 2, 3, 4, 5, 6, 7. And just to emphasize that I've got my whole split into 3 equal segments, let me go ahead and overlap that one with the green, and overlap my 0 with the green. All right, so what am I doing other than ruining my green marker? Is just sort of trying to emphasize that I've got the whole now split into 1, 2, 3 equal segments. All right, and from there, where does 1/3 live? Collect one of those segments. So now I can shade, or where I put those little dots right there, maybe just shade that in this purple a little bit, and maybe I want to label that with a better marker. Let me put 1/3 right there. Okay, what would this mark be? I would collect 1, 2 of them, right? So I could put 2/3 here. And what's another thing I could label my whole now? I've shown that it's 3/3, right? So I know earlier I said I'll put the fractions maybe in the bottom. Well, if the thing starts getting busy, we can do different things. So there's no one right way or wrong way to approach these, just as long as it's sort of legible and readable. Okay, so we did it. So earlier, remember, I kind of estimated where 1/2 might be, where 1/4 would be, and sort of just brainstormed where 1/3 would be. And it was around here, right? So that was a good estimate. But now we know exactly where that lives on this number line. Very cool.